Okay guys, let's go through the two special triangles sheet. It is, yeah, it probably does need some explanation. So here is a square. Mr. Mean rips it in half, but along the diagonal. He measures the diagonal, which has a length of 1. So this is a square, which means all these angles previously were right angles. If we split it down here, then this angle in here is going to be half of a right angle, or 45 degrees. So I've got 45 here, 45 here. Oops, we want the angles in radians. So let's undo those angles that I just wrote and write them in radians. So a 90-degree angle is pi on 2. And then a half of pi on 2 is going to be pi on 4. So all of these angles are pi on 4 and pi on 4. Now let's just call this side length x for now. We don't know what it is. We can use Pythagoras, or we can use sine, cos and tan, but let's use Pythagoras to try and solve for x. So this is a Pythagoras right angle triangle. X squared plus x squared is equal to 1 squared. Oops. X squared plus x squared equals 1 squared. So this is 2x squared equals 1, or x squared equals a half, or x equals root 1 on 2, or root 1 on, sorry, yeah, the whole thing's rooted, or we've got 1 on root 2. Now, we don't usually like having a square root underneath. So if you imagine we times this by this, we times it by 1, this is just equal to 1, so we can times it by 1, then what we end up with is root 2 up the top, and then down the bottom we've got root 2 times root 2, which is just 2. So that's the one we use. It's equivalent to this one, but we prefer not to have a square root underneath. So this side length is root 2 on 2, as is this one, root 2 on 2, root 2 on 2, root 2 on 2. Okay. Now, here is an equilateral triangle. Now, what do you know about equilateral triangles? You know that they have all the same side length and all the same angles. So we're told that the side length is 1. So that's 1, 1. Down here, if we imagine this is 1/2. And the angles are all the same, which means this angle is going to be 60. Hang on, radians. Do you remember what 60 degrees is in radians? See if you can figure it out before I write it. Pause while you try and guess. Pi on 3. Now this, we had pi on 3 divided by 2, so split in 2. So each of these little ones is pi on 6. And these are right angle triangles down there, so that's a pi on 2 and pi on 2. Now, we've still got this height to find, the altitude, the length of the altitude. That's a strange way of saying it, sorry guys. Let's call it x for now. We can use Pythagoras again. So we've got x squared plus a half squared equals 1 squared. So x squared plus 1/4 equals 1. I'm going to subtract 1/4 from each side to get 3/4. Now I'm going to square root both sides, so I end up with a square root 3 on square root of 4, which is 2. And that's what we get, root 3 on 2. Okay, so I'm just going to draw, so our special triangles are, oops, this triangle up here is one of our special triangles. Let me, so this is one of our special triangles. And then this is one of our special triangles. So I'm just going to draw them again up the top of this page to help us. So our first one, oops, is 1, root 2 on 2, root 2 on 2, sorry, that was pi on 4, pi on 4, and then the other one was pi on 3, pi on 6, 1, 1/2, root 3 on 2. Okay, let's just zoom out a little bit. Oops, I can't see where my zoom out button is. There we go, that's a good one. Okay, so this one here. So this, out of our special triangles, is this one, because we've got our pi on 4. So if that hypotenuse is 1, then these question marks must be root 2 on 2. Okay, this one is this special triangle. So here's our pi on 3. That's 1. This has to be 1/2 down here. And this is going to be root 3 on 2. Okay, this one is also our special triangle number 2. So that's equivalent to this one, because 60 degrees is our pi on 6, if you recall. Oh no, it says pi on 6, sorry. 60 degrees is pi on 3. Anyway, it's pi on 6. So this angle here must be pi on 3. Now, we're used to seeing that triangle kind of standing upright, where this side length here is twice that one. Remember, it was the equilateral triangle split in half. So this side length is going to be 6. And then let's think about what this angle is here, this side length here is in relation to the other. So let's think about the scale factor. So our this side length here is root 3 on 2 times as long as that one there. So this one is root 3 on 2 times as long as that one. So this is 6 root 3 on 2, which we can simplify to 3 root 3. So that's the side length here. This one, again, this is our special triangle number 1. It is still normal scale, root 2 on 2. So therefore this one is also root 2 on 2. And that's 1. This one is still normal scale, which is nice. So you should be able to recognize that this is our 30-60 triangle, or our pi on 3, pi on 6, root 3 on 2. And this one, these two are the same, so it's an isosceles triangle, which means these two angles must be the same, so that means they must be pi on 4. And think about the ratio between this side length and this side length. So our hypotenuse, so it's root 2 on 2 to 1. So if this was root 2 on 2 down here, we divide by root 2 on 2 to get this number. So this is 17.2, so this should be 1 on 17.2? No, sorry. It's 17.2 divided by root 2 on 2, which is, we're going to use our calculator over here. Oh no, that sucks. 17.2 divided by, I wonder if I can, anyway, divided by root 2 on 2. Root 2, actually, let's just put brackets in there. So when I divide by that, so 24.32. So let's get back to here. We get 24.32. Okay, that is the end of our two special triangles sheet. hopefully that has made sense. I mean, the most important thing are these special triangles, and the reason they're going to come up as important is because let's just so if you remember your SOHCAHTOA, sine of pi on 4. So remember, SOHCAHTOA is opposite over adjacent. So sine pi on 4 is root 2 on 2 divided by 1, which is just root 2 on 2. Cos pi on 4, here's pi on 4. Cos is adjacent over hypotenuse, so that's always also root 2 on 2 over 2. And tan pi on 4, tan is opposite over adjacent, root 2 on 2 divided by root 2 on 2, which is 1. So this is why these special triangles are important, is because they can help us with our sine, cos, and tan find exact answers. Like usually if I said find sine of a number, you have to put that into your calculator to find the answer. Whereas now, because you are going to get so familiar with these triangles and these values that you can figure these out without a calculator. So our next triangle down here, let's have a look. So let's do just our pi on 6 angle first. So sine pi on 6, so sine opposite over adjacent, 1/2 divided by 1 is 1/2. No, cos cos pi on 6 is adjacent, so here's my pi on 6, so my adjacent side is this one, adjacent over hypotenuse, root 3 on 2 on 1, which is root 3 on 2. Tan of pi on 6, so here's my pi on 6, opposite over adjacent, 1/2 divided by root 3 on 2. So let's just 1/2 divided by root 3 on 2 is the same as times by 2 on root 3. So that those 2's cancel, we're left with 1 on root 3. And remember, we don't like having a root underneath, so if we times top and bottom by root 3, we end up with root 3 on 3. Now this is going a little bit beyond where we're at so far in 14A, but we will come to the point where very soon you're going to need to memorize all of these things. And I'll show it to you in a table, which will make it easier. So you don't necessarily have to draw these triangles each time. So now let's consider the angle pi on 3. So this is the one we're going to focus around. So sine pi on 3 is equal to sine opposite over adjacent, root 3 on 2. Cos pi on 3 equals adjacent over hypotenuse, so 1/2. And tan root 3 on 2 opposite over adjacent, so 3/2 divided by 1/2. Dividing by 1/2 is the same as timesing by 2, so root 3 on 2 times by 2 is just root 3. Okay, let's finish up there. See ya.